Hello, my friends. Today's lesson is on, we're still going to be graphing, and we're still even going to be graphing systems, which we have been doing. But this time we're going to change them. Instead of systems of linear equations, we're going to be solving systems of linear inequations, inequalities. They're not going to be equal to. Inequalities, remember, are the things that have greater than and less than and greater than or equal to, less than or equal to signs in it. So it's going to look very familiar because we've been doing this for so long, but it's also going to have one extra kink at the end, which is not hard. And you've had a similar skills we've taught you earlier in this year. So let's jump right in here. Let me skip over these first couple of pages for checking. All right, so let's quickly review how we graphed by the different forms back in the linear unit when we were just graphing by the different forms. Okay, this one is your y equals mx plus b, right? That's the slope-intercept form, y equals mx plus b. And when we did that one, to do that, remember this b is your y-intercept. And so my y-intercept is 0, -4. Notice I put an x here. I mean, in place of my x, I put a 0. Because at the y-intercept, the x is always 0. So the point 0, -4 would be down here. That's my y-intercept. And then we know that the slope is right here with the m, right? So my slope is 3. So I set up camp at 0, -4 at the y-intercept. Now I'm going to put that 3 over 1 so that I can rise 3, 1, 2, 3, run 1. I'm going to rise 1, 2, 3, run 1. 1, 2, 3, run 1. And that's going to give me, that's how I would graph the line of a, oops, I thought that was going to let me draw a line. Let's see if she does. Let's try this again, right here. Maybe it's not going to let me. Yeah, I want arrows on both ends. Let's try this. Okay, so if I start here, there we go. So it's going to go through there, and it's going to continue forever and ever and ever, right, with arrows on both ends. So that was when we graphed from y equals mx plus b, the slope-intercept form. Then after we did that for a while, then we graphed from standard form. Okay, remember standard form, you put your x's plus your y's equals your numbers. Ax plus by, ax plus by equals your number, see? And so in this one, we found our x and y intercepts, because to find the y-intercept, we set our x equal to 0. Remember, this is x comma y. And to find our x-intercept, we set our y equal to 0. These are our x comma y. So let's go back to the first one. So for the y-intercept, I set my x equal to 0, which means in my equation, I put a 0 in place of my x. Well, 4 times 0 is 0. So that whole thing cancels out, and I'm left with 2y equals 8. Divide by 2 on both sides, and y is 4. Easy greasy. All right, let's start over, and this time I'm going to put to find my x-intercept, I'm going to put a 0 in for my y value. So my y value is going to be a 0. 2 times 0 is going to be 0. So this whole thing goes away because it's just a 0. And now I have 4x equal 8. Divide both sides by 4, and x equal 2. So I've got 2 points, which is all I need for a line. My y-intercept is at 0, 1, 2, 3, 4. My x-intercept is at 2, 0, which would be here. I've got my 2 points. All I need to do now is draw a line. So I'm going to, oh, it didn't pick up on it there that time, but that's all right. Oops, there we go. Don't know what's happening there. So there would be my line right there. So that was graphing from standard form. Then from there, the last form that we did, which you had not had before, it was kind of different. We spent some time on it. was the point slope form. And in the point slope form, we had a point and a slope staring at us from the the equation. And this is what it is. Remember, we had a y minus a number in parentheses equal this number, which happened to be the slope. And then I got my point from the opposite of this x and from the opposite of this y. So my point, I know it's going to go through the point -4, because that's with the x there, and x's always come first in your ordered pair. So it's going to be a -4, comma, then I'm going to jump over here to where the y is, and it's a -3. I'm going to use the opposite of that, which would be a +3. So I know my equation, or my line, if you will, goes through the point -4, 3, and I know that the slope is -2. Well, if I got a point and a slope, I'm ready to graph, right? Because on my graph, I'm going to go to -4, 3 and set up shop, set up camp, if you will. 1, 2, 3, 4, 1, 2, 3. So I'm going to set up camp. And then the next day, after I'm nice and rested, I'm going to slope. I'm going to go hiking. So in this case, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. So there we've got my line, and it will go between the, well, connect all those points. Be better if I had a ruler. So yeah, so there's my line. Okay, so we did y equals mx plus b, how to graph from there. We graph from standard form, and now we've graphed from point slope form. We have to know all those forms and how to graph from them in order to graph systems, more specifically inequalities. So let's first start with this system. This is a system of equations. System simply means there's more than one equations, and their solution to the solving part, the solution of this system is going to be the one point. It's only going to be one point, and it's going to be the one point where these two lines intersect. That point will make this will be true for this. Whoa, what have I done there? That whatever point we come up with, the intersection, whatever xy that is, if I plug it in here and here, it'll make that one right. And if I plug it in x and y here, it'll make that one true as well. So let's see what that point of intersection is. So let's graph. So let's take this first equation. I'm going to come down here. It's in standard form, but that's going to give me some fractions. I think I'm going to just solve this for y and put it in y equals mx plus b to graph it. So I'm going to add 2x to both sides. So I have y equals, I'm going to write down the 2x first because it's my mx, and then plus b would be my -3. So from that, now I can graph. I'm going to go to the y-intercept of -3. And from there, I'm going to start hiking. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I'll draw me a nice line. And when you're doing these, you want to make sure your line's pretty long so that the two lines do actually intercept. Now I'm going to look at this second equation, and let's put it in y equals mx plus b2. It's pretty close to that. I just need to, let's divide everything by -4 to get rid, so it'll be a plain y there. All right, so that's going to give me a positive y equals negative over a negative is going to be a positive, and 2/4 reduces to a half. Then negative over negative, -12 over -4 will give me a +3. So again, now it's in y equals mx plus b. I'm going to go up to 3. And then I'm going to rise over run. I'm going to rise 1 over 2. Rise 1 over 2. Rise 1, rise 1 over 2. I can see where they come together right there. So I draw that line. And the solution, solving the system, the solution of the system is this one point right here where they both come together. That would be the 0.45. So that is the one answer to this problem, 4,5. Now I'm going to show you really quick why that's the answer, how I can prove that's the answer. So I think 4,5 is the solution, right? Let's see if I can get this going pretty fast. So I'm going to take the 4,5. Of course, 4 is an x, 5 is a y. So in this top equation, I'd have -2 times x, which is 4, plus y, which is 5, equals -3. Is that true? -8 plus 5, -8 plus 5. Oh, that is -3. So -3 equals -3. Check. But it also has to work down here in this equation. So let's put it in that one. So -4 times the y, which our y is 5, equals 2 times x, which is 4, minus 12. It was a -2. Does this work? I don't know. Let's see. This would be -20. This would be -8 minus 12. Well, -8 minus 12 is -20. What do you know? It did work in both of the equations. So I am 100% sure that 4,5 is my solution to that system. So what we're going to do today is very, 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 very similar. Oh, okay, let's solve this. Okay, then let's review here. We also solved these systems of equations by substitution, was another method we used other than graphing. We didn't want to graph every time. That gets to be kind of a pain. So here would be a problem. We'd want to use substitution. Notice this x is all by itself. X equal this blob. So that means wherever there's an x in the problem, I can substitute in the 6 minus 4y. You know, when I have a substitute teacher, I am not here anymore. The sub literally comes in my place, and I am not seen anywhere. So I'm going to take this 6 minus 4y. I'm going to take this sub, and I'm going to plug them into this bottom equation wherever I see an x. The x would be me. The 6 minus 4y is my sub. So I'm going to solve the second equation, and in place of x, in place of myself, x, I'm going to put in the sub, 6 minus 4y. And then I've got minus 3y equals 1. 12 minus 8y minus 3y equals 1. -8y, -3y, -11y. 12 equals 1. -11y equals, that's going to be -11, so y equals -1. Now remember, when I'm solving a system, the answer is an ordered pair. It's just one point where two lines intersect. So I've got the y of my problem, but now I need to figure out what my x is. Well, what you do is you run back to the sub. Sub. What's my y? And you just plug it in there. It's going to be x is going to equal 6 minus 4 times your y, which you already found to be -1. So x is going to equal, we always multiply before we add. So it's going to be 6, and then -4 times -1 is a +4. So it looks like x is going to be 10. So the place those two lines intercept, if I were to graph them, they would intersect at the point 10, -1. All right. Moving on. So let's solve these systems, and let's solve these systems by the elimination method. A quick review for that. Okay, the elimination method, remember you're trying to get either your x's to go away or your y's to go away. And you're going to do that by adding opposites to one another. So in this first problem, I want to turn, let's say, I want to turn this 2 into a -4. So I'm going to multiply everything on that first equation by -2. And that's going to give me a -4x minus 6y equals -10. Now watch what happens. Okay, that's gone. I'm going to mark that out. 4x minus 4x, wait, that's a 0. 6y minus 6, whoa, that's a 0. So I get a 0 on that side of the equation. I get a 0 on this side of the equation. I get a true statement. 0 does equal 0. So if you get a true statement there, that means that these two lines are the same line. 2x plus 3y equals 5 might look like this, and 4x plus 6y equals 10 looks like this. They literally are the same line. Well, if they're the same line, how many places do they intersect? Well, here and 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 here through eternity. So that means this has an infinite number, or you can use infinity. I'd rather infinite number of solutions because you can't count them all. They have an infinite number of solutions. All right, let's try this one. Again, I'm going to turn this 7x into a -14. So I'm going to multiply everything up there by -2. So that's going to become -14x plus 6y equals -30. Whoa, the x's cancel out. The y's cancel out. So I'll have 0 on this side of parenthesis. Over here, 15 minus 30 is -15. Wait a minute, my x's and y's both went away. And when they went away, I got a false statement. This is not true. 0 does not equal -15. So what this tells me is that these two lines, one would be here, one would be here, they would never touch. There is no solution. Well, wait a minute, two lines that never touch? What's that called? Oh, these are parallel to one another. And they have no solution to the system because they never touch. Okay. So remember, and get this in your notes. If both x's and y's eliminate, if you're left with a true statement, that means the two lines are the same line. So the solution is an infinite number of points on the line. If both x and y eliminate and you get a false statement, that means the two lines are parallel. So the solution is no solution, non-existent, because the lines never intersect. Okay, that was all a review. And I'm going to stop here for a minute, and I'll pick up this when I get back. Okay, so we're going to take a break here and go on and you can shut off your video. I'm going to start the inequalities piece on the new video. So it'll come right after this. So stay tuned.